In this video, I'll be showing you the basic idea of a regression. So let's say you've got these data points here. The x coordinates are the age of a certain pet. Let's say you work at a pet clinic and you log this information. And you have the weight of a pet. Let's say here we got a 1-year-old pet and they weigh, let's say 6 pounds, they weigh 2 pounds. And let's say we got a 10-year-old pet, they're gonna weigh 19 pounds. How could you predict how much a 19-year-old pet would weigh here? How about a 17-year-old one, 15-year-old one? To do that, you need to use regression. Okay, so regression is basically when you have data points here and you just try to find the pattern. So this is just one example of a pattern we could do, just tracing all the lines and then guessing here. One of the most common types of regression you'll see in statistics is just a straight line. This, called a linear regression. This is exact. You can move it around a little bit, like maybe here or here. You could even try a quadratic regression to see how well that fits it, like this. Clearly it's not too good in this case. Maybe if I drew it better, it would be a little better, but looks like that's not it. So let's put this into Desmos to see what the line of best fit would be here. Remember, the line of best fit here, since the line would keep on going, we would be able to find how much a 19-year-old pet would weigh. Okay, so let's go into Desmos. Okay, so we've got our x's here and our y's here. And we know this is a line, so we're going to put y equals mx plus b. But we get an error. It says too many variables, try defining m or b. The problem here is, when we just say x, it's not sure of which x we're talking about. So we have to say this x, these x values. So we're going to put x1, and same thing for the y, because there's no which y we're talking about. So we put y1. Okay, and the final thing is we're going to put a squiggly line. This squiggly line just means, to the best of your ability, find what m and b are. Just try to find the slope and the intercept. So we're going to do that. We're going to place it with a squiggly. And there it is. Here it's telling us the slope is approximately, just right out here, 1.95x minus 0.133. And Desmos here has created the linear regression for us. It found the line that best fits the points to the best of its ability, and it gave us the equation of the line. We could keep doing more complicated regressions like the quadratic one we saw earlier. So, same idea here. Just say y equals ax squared plus bx plus c. Just remember, we got to be really literal in what we're referring to. If we want to talk about the x's, we have to specify which x's. So here we have a table with x1 labeled, so let's refer to that here. Same thing for the y. And finally, since it's a regression, we're going to use a squiggly line. Okay, let's see how well these points match up. Not too bad. But here, the problem would be, once your pet reaches a certain age, it starts to go down again. Could depend on the pet, but this might be weird considering some pets. So I would probably stick to a linear regression here. Okay, and here are these numbers. What do these mean? Okay, it told us what it thinks m is and what it thinks b is. This r squared is called the coefficient of determination. It basically tells you how well the model predicts the data, how much variation it explains. Okay, that's r squared, and it's 0.9745, which means it's pretty close. The closer to 1 it is, the better. Okay, in our next one here, we have r is equal to 0.9872, and this is just the correlation coefficient. It means how well it can predict positive or negative trends, or how closely they align. So if it's r equals 1, it's going to be like this, y equals x. Or something. Just a perfect straight line, goes up, positive slope. Okay, let's see how we can use this idea of regression for other problems. So let's go to this one. So we got this sequence, and we want to predict what the next number is. We got 1, 3, 6, 10, 15. And here in the data table we have it. The first number is 1, the second number is 3, the third number is 6, the fourth number is 10, and the fifth number is 15. this gives us some data points to work with. So you how to put these into Desmos. If you're just working with a raw data set, you need to put it in. Okay, we're going to go to table. Let's label our x's and our y's. It automatically put x2 and y2 for me, but you can put A, B, C, D, put whatever letters you want for that. Okay, so we got 1, 1, 2, 3, 3, 6, 4, 10, and 5, 15. Okay, let me just make that one invisible. Okay, just from these data points alone, it looks like a parabola. I mean, just look at this curve. Okay, so let's use what we learned. When it's a parabola, so it's gotta be of the form ax squared plus bx plus c. And then we replace these variables. And you don't have to do it slow like this. You could just put in x2 immediately if you got that drilled down. Okay, y2, and then squiggly line telling it to find a, b, and c to the best of its ability. And there we go. This quadratic, it passes through all the points perfectly. So here, r squared, the coefficient of determination is 1 because it perfectly matches the data set. And it explains all variability. Okay, and here, let's see what it tells us about the quadratic. Okay, it says, I think a is 0.5. So squared, so just put this directly, 0.5x squared plus 0.5x plus 0. Okay, and it seems right. It matches all the data points just like the regression it made. So yeah, the function rule for this one would be 0.5x squared plus 0.5. And you could even use this to find future points. Let's just call this f of x. If you want to find the 7th number sequence, or let's say the 70th, you plug in f of 70, and you'd get 2,485. And same thing for this line. You did want to find the weight of the aforementioned 19-year-old animal. You'd go back here, and you would plug in 19 into this line. So 1.95, which is type it manually here, times 19 minus 0.133. And it says, okay, if we use this, let me just move this here. Here we go. If we use this line, then it thinks that 19-year-old animal is going to weigh about 36 pounds. So just look here. X equals 19. Okay. Yeah, it says that's going to be about 36 pounds if we just keep this linear trend going. Okay. And one other thing, when we do stuff like this, when we're predicting outside our data set, like where we're going outside, this is called extrapolation as opposed to interpolation. So interpolation, just really quickly, is when you're trying to guess points in between. So we know the weights of a 7-year-old and an 8-year-old pet. Interpolation was if we found the weight of a 7.5-year-old pet. This one's a little easier to do since you can just eyeball it. It's going to be about in the center here. Okay, and that pretty much covers it for regressions on Desmos. Hope you enjoyed this video.